It took 4 heavy lift helicopters to begin the process, before the divers could attach the massive lifting frame deep below the surface.
This monumental recovery effort began with the raising of the derelict hull. Then, around the clock, hundreds of
Bring her down steady now, easy on the hydraulics. We have splash in 3, 2, 1. And the ROV is in the water, bridge.
Using the latest sonar technology, the team uncovered the massive hull of the sunken carrier resting on the seabed.
Mark that position.
Okay, sample secured. Switching to the sensor now. Pressing against the patch. Confirmed, reading steady at 11.5.
The ROV spotlight reveals the twin anti-aircraft turrets, now heavily encrusted with barnacles. As the ROV moves through the jagged tear, the spotlights reveal the extent of the internal decay, highlighting the silt-covered decks below. The ROV slowly penetrates the massive hull, entering a darkness undisturbed for decades.
Okay, easy now. We've got a positive grip on the target. Bringing it up slowly. Watch the sediment.
The ROV arm successfully deposits the metallic sample into the collection bin. These fragments will now be brought to the surface for analysis.
Pushing through the rusted hatch, the ROV enters a vast chamber. Here, massive,
Deep within the wreck, the pressure gauges show the immense stress on the hull, though the readings are obscured by time and corrosion.
The ROV's manipulator arm engages the motorized brush to clear the silt from gauge BG-4, revealing the critical pressure reading beneath.
We have stable readings across the board now. The cleaning sequence worked.
Check the thermal regulator gauge again before we proceed.
Emerging onto the vast expanse of the flight deck, the spotlight catches the silhouette of a massive twin-barreled gun.
As the ROV breaks the surface, its powerful lights pierce the murky depths, revealing the mysteries of the abyss.
Lower away, watch the stern.
Descent looks good from here. Checking pressure.
Okay, surface, I'm starting the suction now. The silt is thick here.
Powering up the hydrocutter now. Stand by for ignition. Copy that. Maintaining position.
Keep the pressure steady. We're almost through this section.
Surface, this is Diver 2. The acoustic sensor is deployed and secure. We are ready for activation.
The delicate process of underwater welding requires precision and specialized equipment, especially when dealing with a deteriorating hull.
Once the valve is open, the pressurized air rushes into the bags, beginning the delicate process of lifting the wreckage from the seabed.
The lift bag is fully pressurized. The shackle seems secure, but the corrosion here is significant.
This is perhaps the most critical job for a hull diver, clearing the massive buildup of rust and barnacles.
I'm focusing on frame 7. The seam here shows significant pitting and clear signs of advanced metal fatigue.
The high-pressure jet scours the hull, removing years of accumulated marine growth in seconds. We are making good progress on the starboard side.
Connection is good. Take the strain slowly.
As the recovery operation commences, the immense structure slowly yields to the heavy cables.
The pressure is holding steady at 500 psi. System integrity confirmed.
Decades underwater have transformed the massive hull into an artificial reef. But deep within the wreck lie secrets waiting to be discovered.
The ROVs carefully attach the specialized explosive. Once the area is clear, the charge is detonated.
As the crawler moves slowly along the hull, it stirs up thick clouds of silt, a necessary step before salvage operations can begin.
Ready? Lean into it.
It's coming loose. Watch the silt.
Diverse, confirm status.
Acknowledged. We have a clear visual on the anomaly. Zooming in now.
All systems green. Ready for deployment. Watch the line. Lower it slowly.
On the surface, the ships strain against the weight. Below, the massive cables pull taut, revealing the sheer scale of the wreck amidst a cloud of disturbed silt.
Cable D4, tension nominal. All systems green. Lift proceeding safely.
Okay, the caliper reads 210 millimeters. Recording the measurement now.
As you can see, the red indicates severe stress. We need immediate stabilization on the port side or we risk total collapse.
As the divers approach the massive wreck, the sheer scale of the disaster becomes apparent. The submersible provides much-needed light in the deep blue.
These massive winches are designed to withstand incredible tension, slowly hauling the sunken vessel from the deep.
As you can see, the stress analysis shows the highest load right at this junction point.
So we should reinforce the casing based on this data.
The tension on the cables reached critical levels, and then, slowly, the massive hull began.
The hull begins its ascent, tearing free from the seabed for the first time in decades. The resulting silt plume drastically reduces visibility.
Okay, the growth is heavy here. Suction is engaged. The high-pressure jets are essential for clearing the heavy silt and revealing the structural integrity of the hull.
The team uses high-pressure water to reveal the access point on the hull of the mighty BG-2.
The telemetry readings are spiking. I need a diagnostic on the main thrusters now. We're losing stabilization.
Emerging from the depths, the carrier represents a monumental feat of engineering, a relic returning to the surface world.
Look at the extent of the corrosion right here. The structural integrity is severely compromised.
The sensor readings confirm significant degradation below the waterline as well.
Yeah! All right, that's perfect. Great job, everyone!
Surrounding the rusted hull, the bright yellow BG-5 buoy system provides the critical buoyancy needed to stabilize the massive structure against the ocean swells.
The pump's ready. The pump's thousands of gallons of silty water daily. Underwater.
The rusted behemoth, once a symbol of power, is slowly towed to its final resting place by two determined tugboats. This colossal relic of the Cold War, weighing over 80,000 tons, is slowly being pulled across the Pacific.
The colossal hull of the BG-7, a relic of naval history, begins its final descent. The hydraulic impact wrench provides the necessary torque to secure the massive bolts deep underwater, a critical step for hull integrity.
All right, throttle up. Make sure the starboard nozzles are clear.
The immense scale of the operation becomes clear as the dry dock brings the carrier to the surface. Water pours from the rusted hull at an astonishing rate.
Welding the flight deck requires precision, even in these close quarters. The heat alone is enough to melt standard alloys.
This colossal vessel, once a symbol of power, is now on its final journey across the open ocean.
This delicate operation requires absolute precision. The tugboats strain to guide the massive
As the massive caisson gate begins its ascent, the sheer volume of water displacement creates a violent churning effect.
The ultrasonic readings on frame 212 show significant degradation. We have to prioritize that section before surge floating.
Understood. I'll update the maintenance schedule.
Guiding a supertanker into the BG-8 dry dock required immense precision. High-pressure water jets stabilize the massive hull as it slowly moves into position.
As the carrier enters the basin, the massive pumps begin deballasting, creating the spectacular spray you see now.
Towing a supercarrier requires immense precision. These 4 tugboats are guiding the 100,000...
The coating looks good here, but we've got some spots missed just above the waterline. Okay, instruct the team to focus on that upper section near the anchor housing.
Ensure the master switch is engaged before adjusting the primary flow dial. Keep an eye on the pressure gauge.
The sheer volume of water moving through this facility is staggering, highlighting the immense power required to manage the flow.
As the water level drops, the true scale of the vessel becomes apparent. The pumps expel the turbulent water, revealing the concrete floor beneath.
We have significant pitting around the waterline.
Copy that. I'm logging the coordinates now.
Here we see the rapid construction of the support structure. designated BG-3, essential for the repairs.
The BG-5 is essential for removing these stubborn barnacles, a critical step before repainting the hull.
Almost there. Keep pushing. Yeah, this stuff is heavy. Keep it steady now, push right through the center. Okay, I've got it. Watch the sparks. We're clear on the starboard side. Copy that, moving to the next.
Okay, that's the last of this section.
Copy that. Sealing the bag now.
All stations maintain current output. We have a green light from Section 4.
The laser scan confirms the structural integrity of Section 4. The heat map indicates only minor stress points near the bow.
All right, this joint is completely seized. We'll heat it up and then hammer it loose. Then we tag it with FDAG001.
As the turntable rotates, the red laser lines project a mesh onto the surface, which the software then translates into a high-resolution 3D model.
Watch the sparks, I'm almost through the beam.
Got it.
It's moving.
The ship's new long-range radar is a critical component requiring careful installation. Clear to lift on the north side. Watch the tension.
All right, mark this one FIRM-222B. Check it against the specs.
Confirmed, looks good here.
Take it up another 10 feet and hold it there.
10 feet, confirmed. Watching the cables closely.
Keep going, you've got it! Watch the pressure gauge.
Watch the starboard side.
Clear on the catwalk, bring it up slow.
Copy that, slow hoist. All hands, clear the flight deck immediately. The BG-18 lift is in progress. Stay clear of the magnetic load.
Scanning the primary cables now. The tension analysis shows optimal status. No degradation detected.
Take it up slowly now. Watch the clearance on the left side.
Hold the grinding on the lower blade. We're bringing the hook down now. Copy that, holding steady.
Using a thermal lance, the workers slice through the thick steel, opening up the massive structure to the outside world.
Labeling the artifact now, we'll call this one Sample T.
So if we rotate this section here, we can see the stress points on the inner flange. The tolerances look good.
Make sure that's centered. We need this beam moved by 3 o'clock. We need that beam lifted to Section 4.
Copy that. Watch the clearance on the BG-25 hull.
Watch the clearance on the left. Easy now, easy.
Bring it down 10 more centimeters. Set it down right there.
This high-pressure stream effectively strips away years of corrosion, revealing the pristine metal underneath.
You have to get the slag off while it's still hot, otherwise it's much harder to see the quality of the joint.
Sinking low. This massive CNC plasma cutter moves at incredible speed, demonstrating the efficiency of modern fabrication as it
Coming down slowly, keep it steady.
Move it left, just a fraction.
And hold, stop right there.
Here at the shipyard, the massive hull receives its first coat of anti-fouling bright red paint, essential for protecting the steel.
That looks aligned. Yeah, hold it there, I'll get the next one. Okay, easy now. A little to the left. Perfect, set it down, we got it secured.
Precision is paramount when fitting the portholes. Then, in the dry dock, the massive hull receives its vital coat.
The scale of the dry dock operation is immense. Precision is paramount, from the initial coats of paint to the constant monitoring by the survey team.
The red beam captures thousands of data points, creating a detailed 3D wireframe of the hull in real time.
Once the massive components are in the dry dock, smaller, intricate parts like these turbine gears must undergo a specialized... Precision is everything. We measure to the micron, then the machinist takes over, ensuring the final product is flawless.
Ready on bolt 7?
Ready?
Pull.
All right, slowly now. Bring it left a fraction.
Looks clear on this side.
Okay, hold it there and set it down.
All right, the hydraulics are engaged. Rotation looks good. We are clear for the stress test.
Precision is key here. We're monitoring the current flow across the copper to ensure stability under load.
Operating at high velocity, the braiding machine weaves the synthetic fibers tightly around the thick multi-strand copper core.
The intense heat of the arc flash reaches upwards of 10,000 degrees, fusing the steel pipe joints together permanently.
This tiny brass gear is the heart of the movement, requiring a steady hand and years of experience to set correctly.
Elevate to 30 degrees and hold. Ensure the breech is sealed before cycling the recoil mechanism.
The readings on all 3 gauges confirm the BG-49 winch is operating well within the specified safety parameters.
Bring her down slowly now. Watch the clearance. Clear on this side, lead. A little to the left. All right, hold it right there. Easy. All right, easy now. Keep the rotation steady.
We are clear on this side. Lowering.
Keep going, nice and steady now. All right, that should do it.
Got it.
Torque is within spec. Lift the slack on this yellow one.
Bringing it up now. All right, easy now. Set her down gently.
Watch the alignment on the starboard side.
Looks good. Keep coming down slowly. We are almost there. Keep that line steady. We need full penetration on this joint. Almost there. Just a little more heat.
Slowly now, watch the alignment as you turn the crank.
Almost there. The bolts are secure on this side.
From the flight deck operations to the meticulous work in the dry docks, these vessels require continuous effort to maintain readiness.
Once finished, the blue, red, and white pattern will protect the hull from the harsh elements at sea.
Keep it steady on the left side. All right, pulling back now. Looks good.
The engine order telegraph was how the bridge communicated directly with the engine room. Keeping it pristine is a matter of respect.
Watch the bulkhead on the left. Okay, easy now, bring it down slowly. And set.
There we go, that's firmly in place. We should have full illumination down this corridor now. Hold it right there, wheels are down, chocks in now. Secure the chains, double check the tension.
Hey, is that engine room sign ready yet?
Yeah, just finished securing it. Looks good.
Curating this exhibit meant connecting seemingly disparate histories, like these early flight helmets and the naval vessels they eventually served on.
Inspection report, section 3. All gauges reading within tolerance. Moving to the auxiliary pump next.
Radar contact holding steady course. Logging the coordinates now.
Attention to all personnel. Hangar Bay 3 clearing operations are proceeding on schedule. All hands remain vigilant.
This immense engineering effort is designed to lift the 100,000-ton vessel, a process requiring precise timing and vast amounts of water.
At over 1,000 feet long, the aircraft carrier presents a monumental challenge for the tugboats guiding it through the bustling harbor.
Pull hard now, lift on 3. 1, 2, 3, heave.
Got it.
Clear the line, nicely done. Okay, that's seated. Let's get the wrench on there and secure it tightly. Can't have any leaks with this pressure. I tell you, they really rolled out the red carpet for us today.
Absolutely magnificent. Listen to that band play.
It brings back memories, doesn't it?
Utilizing the latest in sonar technology, the team was able to render a complete three-dimensional view of the sunken vessel.
The anomaly is directly over the main deck.
Confirmed. The signature is unusual.
The ROV is now engaging the hull, attempting to collect core samples from the compromised structure.
Reading confirmed, we have 28.55 millimeters.
Penetrating the hull for the first time, the ROV lights reveal a cavernous space choked with silt and the remnants of the ship's wiring. The claw has successfully latched onto the artifact known as BG-11. It is now lifting clear of the wreck.
Control, we have a confirmed contact. Sonar reports indicate a large caliber shell. Designate as UXO.
As the sun sets over the harbor, the immense vessel, fully restored, is guided triumphantly